begin by talking about projectile motion, right? So the first thing I want to go over is this equation here, right? So we have projectile motion. That means anything that is being thrown upwards, right? Anything that we're throwing up in the air, we can use quadratic equations to model those scenarios. So for example, if we look here, all right, just to kind of cover it, the negative 4.9, that comes from gravity. Gravity's constant is negative 9.8. 9.8 meters over second squared. This is actually gravity's constant, right? This is the constant acceleration that gravity pulls an object down. And since an object is pulling it down, that's why it makes sense that it's a negative sign, right? Well, when we're dealing with an equation like this projectile motion scenario here, because we have this t squared, right? Well, that's going to be half of 9.8. And that's why we're going to get the negative 4.9 here. But that's pretty much in this equation, that negative 4.9 or dilation comes from gravity. All right, well, the number in front of t, or x squared, is velocity. It's the velocity that an object is thrown from. And then the h is the height that an object is thrown from, right? So if we go down to this scenario here, we have Mr. Arellano throws a basketball at an initial height of 1.77 meters with an initial velocity of 6.85 meters per second, right? So I have the video to show you. This scenario comes from this right here, and we want to find out, right, how long will it take for the object to reach the highest point. So maybe I should have wrote that here, is we want to determine, so let me go ahead and write that in there right here, determine the highest point, or determine how long it takes to reach the maximum height. Okay, so I'll put that over here. This is the second part of the question here. Determine how long it takes to reach the maximum height, right? So ideally what we're trying to do is right here, we're trying to determine when it reaches the highest point, right? And if we kind of go through it, we can kind of see maybe that we want to find out how long does it take for the object to reach this point right here, the highest point from the ground, right? Well, if we were to kind of draw a picture, right, this would look something like, let's go ahead and draw a picture. This is me over here, and I'm throwing the ball, and it's going to go in like that, right? And then it's going to hit the ground and bounce. We're trying to determine this point right here, the highest point. Well, that's a quadratic, looks like a quadratic equation that's reflected over the x-axis, and the maximum point is our vertex, right? So when we write our equation, we're going to get y is equal to negative 4.9. All right, I want to write x because it's kind of sloppy with this pen that I'm using, x squared plus, right, we look back at our equation up here. Well, the number that goes here is our velocity. So the velocity was 6.85x plus, and then finally the initial height that it was thrown at, right? The height the object is thrown at, which is this term right here. So the h, and that's going to be initial height of 1.77. So 1.77. Great. So now that we have our equation for this, right? We have our general form equation. Well, what can we do to change this into vertex form, right? We want to determine the highest point it reaches. Well, if we were to kind of graph this, you know, let's go ahead and graph this here. Oh, let me go ahead and, all right, we got something that's like this. Let's go ahead and graph it. All right, well, we want to determine right here, right? This is going to be the seconds it takes for it to reach this point here, which is going to be the height, right, for our y-axis. So this is the height. Okay. So that's what we're trying to do. We're trying to determine that. So we want to change it to vertex form, right? And so just like we did on the other videos, all right, I'll go ahead and lower it down. Let's change this. We just change this to vertex form. It's really similar to the problem that we did beforehand. First thing we want to do is we want to pull out the negative 4.9. Right? So we're going to get, we had to divide by negative 4.9 to both terms. All right, well, we do that. We're just going to get x squared here. And then this is where I'm going to rely on my graphing calculator real quick. Sorry about that. Okay, so let's go ahead and do 6.85 divided by negative 4.9. I don't know why I drew this extra one here. That shouldn't be there, right? We're dividing by with the term that's here, which is a negative 4.9. So if we do that, we're going to get negative 1.39. I might just round up. Negative 1.4, okay? So we're going to get minus 1.4 and x. Don't forget that we still have this plus 1.77 out here, right? So now that we pulled out that first term, now we want to turn this into a perfect square. So to turn that to a perfect square, what we want to do is, just like we've done before in the past, we want to write it, right? X squared minus 1.4x plus blank is going to equal x plus blank squared. Well, what do we do to this term here to get this term out on the outside? Well, we're just going to divide this by 2, right? And this is going to be, so let's just go and do it, negative 1.4 divided by 2. Oops. Negative 1.4 divided by 2. And that's negative 0.7, so we're going to get negative 0.7, right? And now we just multiply it by itself, negative 0.7 times negative 0.7, all right? We should get the points here. So negative 0.7 times negative 0.7 is going to be a positive, because the negatives cancel out, 0.49. So 0.49. Okay. So that's going to be the number that we want to add inside here, right? And then, of course, we got to subtract it like we did on the other video. So now I'll go ahead and write y is equal to negative 4.9 x squared minus 1.4x plus 0.49, right? But if we add it, we have to subtract it, minus 0.49, and then multiply it by our dilation, 4.9. Don't forget that we still have this plus 1.77, so plus 1.77, okay? Now that we have go ahead and done that, we'll just go ahead and solve it. Because if you look, sorry about that. If you look here, the x squared minus 1.4x plus 0.49, well, that's right what we have up here. And this equals x plus negative 7 squared. Right, so we're going to get y is equal to negative 4.9, and we're going to get x minus 7 squared, right? You could do plus the negative 7, but that's just the same thing as x minus 7, and I'll just leave it like that. Sorry, I apologize, the 0.7, so it should be 0.7. All right, and now we just need to simplify this entire thing here, right? So I'll just go ahead and simplify that on my calculator here. So we're going to get negative negative 0.49 parentheses, negative 4.9, right? And then we're adding the 1.77. And we get 4.171. So plus 4.17. I'll just go ahead and write it like that. Perfect. So now that we've got our vertex form, right, and this is the height of the object, well, this section over here is negative, right? And so we kind of want to avoid that because we can't have negative time. We're going to get positive time, right? So the ball went something like this, and then it hit the ground, and then it bounced up. Well, we want to determine, right, the maximum height. When it hit that, well, this is what this equation here is going to do. It's going to tell us that spot, right? Well, look here. What does the x minus 0.7 tell us? Well, it tells us to move to the right, right? It's always the opposite, to the right by 0.7. So this is going to be 0.7 seconds. Okay. And then at 0.7 seconds, this tells us to go up. Well, up here, it's going to be 4.17, right? So at 0.7 seconds, it reaches the maximum height of 4.17 meters. All right. So we can go ahead and finally answer the question here. And we could just write it down if we want to, that it took 0.7 seconds for it to reach the maximum height of 4.1 meters. All right. And there we go. That's my answer, and I've answered the question correctly. And you notice that it required us 4.17. Oh, I forgot to add the little 7 here, but that's fine. All right. So we'll notice here that in this problem, it required us to go from general to vertex, right? We started up here with the equation. Oops. We started up here with the equation, and then it required us to go to vertex form here to allow us to tell us when it was going to obtain the highest point and how many seconds it would take.